Hello, May class, and welcome to your next maths lesson. So, in today's lesson, we are continuing our work with fractions, and I'm going to start with the arithmetic. So, I will read through it. Please make sure you have a piece of paper and a pencil that you can use for this, and number 1 to 10. So, your questions are as follows. 5 times 7. What is 18 shared into 3? So 18 shared into 3 equal groups. What is 823 as a Roman numeral? What number is next in the sequence? 1, 2, 3, 5, 7, 11. What is 9 times 9? What is 32 divided by 8? What is 3 kilometers in meters? 6,788 plus 2,231, 9,875 minus 2,462, and 42 divided by 7. So in today's lesson, we're going to understand better at what 1/10 is, a tenth. So say that with me, tenth, tenth. We're also going to look at counting squares in a shape to find the area. So I want you, as a quick challenge, to have a look at this number. It is 4.369. What does each digit represent? And can you rearrange the digits to make the smallest number or the largest number? And can you make it an even number? How would you change this to make it an even number? Okay, so when we're looking at a number, if we have this dot here, this one here, we call it a decimal point. All numbers have a decimal point and it never moves. So your decimal point will always be in the same place. We only show it when we have numbers that are not a whole. And the first number after the decimal point, so on the right-hand side, this one here, we call our tenth. So if you can imagine that we have our columns that we would normally have for our numbers. Okay. This one here is our hundreds column. This one is our tens column. This one is our ones column. And now they're saying if this is our decimal point, and our decimal point never moves, the first column after our decimal point is what we call our tenth, right? It is a tenth. This is obviously our ones, our tens, and our hundreds. So take a moment and have a look at that. So we have our hundreds, our tens, and our ones. Then we have our decimal point, and then we have our tenths, right? And look at how it is spelt. So that is obviously our tenths column. So tenths are fractions that always have 10 parts. In our live lesson, I went over this with you. The idea that when we have our fractions, they are fractions of a whole number, and the denominator tells you how many parts that whole has been broken into, and then the numerator at the top will tell you different things. So for example, if I said to you, if this is 10 counters, what fraction of the counters is green? You would say it is 1/10, because it is 1 out of 10 of the fractions is green. Then you would say, what fraction of them is yellow? What fraction of them is red? So let's look at it together. So it says here, Tenths are fractions that always have 10 parts. They are made up of 10 parts. There are 10 parts here. I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many of the counters are yellow? 3 of the counters are yellow. 1 of the counters is green, which means 6 of the counters is red. If you were to write this in a fraction, remember your denominator is the amount of parts that make up your whole. So in this case, our whole is made up of 10 equal parts, of which 3 of them are yellow, 6 of them are 6 of them are red, and 1 of them is green. That would be the fraction of the different colors within that whole, and the whole being all of these counters together like that. Okay. If we're looking at making a part whole model, we can use a part whole model to help with our fractions, remembering that one whole is the number. It means we have a whole number, and our fractions are parts of that whole. So if I can see this part here says it's 3/10, I know that my 1 is made up of 10 parts. So 10 out of those 10 parts would be one whole. If I had to draw it for you, I will draw it as a rectangle as best I can. Okay, just gonna put it into. I'm trying to do this as equally as I can. Okay. No. Oh, I've just given you too many. So 6, 7, 8, 9, 10, and I'm just going to erase, if I can, erase this bit here, because that is not part of our, it won't let me. Okay, so imagine, if you will, I'm going to undo all of it. Actually, imagine, if you will, that we have got a shape that is broken up into 10 equal pieces. Let's see if I can do it here. Right, so that makes it 5. And this will make it into our 10th. Right, so we have 10 fairly equal pieces there. And that makes up our whole. So the whole shape, if I had to color in all these pieces, it would be 10 out of 10, which equals, so 10 pieces out of 10 equals one whole. Okay, I can see that this has been broken up. We've got 3/10 there. What do we think will go here? So if I know that 3 out of 10 has been colored in, so we've got 1, 2, 3. If 10 over 10 is equal to one whole, okay, what is going to be here? We can use the model that I've drawn to work it out. So if we have a look, we'll use a different color, and we're going to see 1, 2, 3, 4, 5, 6, 7. 7 parts out of the 10 are not colored in, which means if we have a look and we say 3/10 plus 7/10 is equal to 10 over 10, which is the same as one whole. So I want you to have a go at writing this or doing these. So it says, try answering these questions. Tick the pictures that show tenths. So remembering what I said, that tenths are a whole number that has been broken up into 10 equal pieces. And then can you have a go at finishing the part whole model that is on the right-hand side? So pause the video now, and then I will go through the answers with you. So it says that we need to tick all the pictures that show tenths. So what you're going to do is in each shape, you are going to count how many parts it has been broken up into, and that will tell you whether or not it's a tenth. So let's do the first one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it into 10 equal parts? Yes, it is. Let's look at this one. 1, 2, 3, 4, 5, 6, 7, 8. That is 8 equal parts. 8 over 8. So is that a showing tenths? No, it isn't. This one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That one is showing tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 pieces there. And that is not showing tenths. This one, 1, 2, 3, 4, 5 are red and 5 are white, which tells me in total there are 10 beads there, out of which 5 are white or 5 are red. So that is showing us tenths. It's just showing us 5 tenths. This one here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 flowers in total, of which 6 of the flowers are yellow, 4 of them are blue. So our fraction would either be 6 out of 10 or it would be 4 out of the 10 are, I don't know why I did that. 4 out of 10 are, sorry. 4 out of 10 are blue. So this one is showing us tenths. So tick or put a dot next to the ones that you got correct. If you didn't get it correct, can you see where you have made a mistake? This question here, it says if 1 is our whole, 1 can be made up of 10 out of 10. And we would assume that it is 10 out of 10 because this one is showing us 7 out of 10. So this one here would be 3 out of 10 because I know that my whole is 10 out of 10 and I have got 7 out of 10 and I know that 7 plus 3 will give me 10. So the one that's missing is 3 over 10 or 3 tenths. So your independent task, the first one, is the following. It says, Amir has some blue and yellow cubes. He makes a tower using 10 cubes. Investigate how many different towers Amir can make with 10 cubes if every tower has a different fraction of blue or yellow cubes. So for example, the one that has done here, you've got 2 tenths are yellow, 8 tenths are blue. I could also have 3 tenths being yellow, that would make it 7 tenths being blue. I could say that we can have, we could have 5 tenths could be yellow, which would make 5 tenths blue, because 5 and 5 makes 10, and my whole has to be 10 cubes. Okay, so pause the video now and answer the first question. How many different towers can he make? Imagining that he's got 2 big lots of blue and yellow cubes, but to make a tower, it has to be made of 10 cubes, of some with blue, some with yellow. How many different towers can he make, and what would the fraction of the cubes in those towers be? Question 2. Danny has a bag of sweets. Half of the sweets are red. 3/10 of the sweets are yellow. What fraction of the sweets are green? Now, we have done a bit about equivalent fractions that are equal with the same amount, with different amounts, but I want you to think for a minute that if you have got 1, 2, 4, 6. If I've got 10 cubes, right, how many of those would I color in to have half the cubes? So what would half of 10 be? Because that is what we're looking at. So how many out of 10 would you have to color in, or would you have to make it that you had half of them? And that will help you with this, because then you would take the answer to this one and add your 3/10, and then you would work out then what the red and the yellow ones were together and how many you needed to make for the green ones. The final question is the following. Mo also has a bag of sweets. 4/10 of his sweets are red. The rest are green or yellow. What fraction of Mo's sweets could be green? What fraction could be yellow? And how many possible answers could you find? So think about the fact that there is a mixture of green and yellow sweets left. Okay. So what could the fraction be? You will have more than one answer for how many green ones he would have, how many yellow ones he would have, and then write down all your possible answers for that question. Don't forget to share your work with us on Tapestry. Please make sure you are laying your work out neatly and have your work up by 4 p.m. this afternoon.